Hello and welcome back. We're covering another early concept video of what's covered on the ACT math test. This one's a little bit more generic with general equation use and manipulation, but it's equally important as all the others with a few good tips in here. As always, if you find it helpful, leave a like, subscribe, comment with anything you'd like to see more or any questions you have, and let's get right to it. So, what do I mean when I'm talking about general equation use, manipulation? What problems are we talking about? Things where they're just going to give you a random equation. A common one that you might see is something like converting between Fahrenheit and Celsius. That's what I'm going to use for most of my examples in this video. But it could be anything. But the important thing is you don't have to have it memorized. They will give it to you. And they will ask you to either just the simple version of just plug in a number that they give you and solve it. That's not too bad, but there are some important little reminders for that. Another one would be to manipulate or solve that equation so that you are rewriting it to solve for a different variable. So looking at that Fahrenheit Celsius, if they give you the formula solved for Fahrenheit, they might ask you to solve for Celsius, either as the equation in variable format or with a number. And finally, very similar to that, they might ask you to simplify or manipulate an equation or expression to give an equivalent form of the equation. So not necessarily solving for a different thing in there, but rearranging it or simplifying it to a different form. So we'll go through these in order, with the first being the simple plug in and solve. It's the most straightforward, but there are a few key things to remember. First of all, make sure you follow your order of operations. If you don't remember that, the expression is PEMDAS for parentheses, exponents, multiplication or division, addition or subtraction. So do anything in parentheses first, then anything with exponents, then anything with multiplication or division, those two are equal, and finally anything with addition or subtraction. Those two are equal. Also, don't forget to double check your units. If they tell you that an equation is used for certain units, just make sure what you plug in is the correct unit. If it's not, you might have to convert first. For example, if it says an equation uses feet and they give you a number in inches, make sure that you convert those feet or those inches to feet. So a quick example of that, use the following equation to convert 43 degrees Fahrenheit to degrees Celsius. Here's my equation. So remember, here's PEMDAS. So first thing we'll do, we'll plug in that 43 for the F. So that gives us this right here. I haven't done anything but put the 43 in. Then, going through here, anything in parentheses. So that's going to be the 43 minus 32. I'm not going to multiply by 5 first. I'm not going to divide. I'm just going to do this stuff in parentheses. So 43 minus 32 is 11. So now I have 5/9 times 11. Then there are no exponents, so we go to multiplication and division. Those are equal. So I multiply the 5/9 times 11 and get 55/9, and that is 6.11 degrees Celsius. Now note, you have a calculator, so you could have plugged in with your calculator at any point starting here where it's all numbers. Just be very careful that you use your parentheses correctly when plugging into your calculator. It makes for one of the most common mistakes I see, where because they don't put the parentheses, their calculator is going to go order of operations, but you didn't actually put it in the correct way. So if you want, feel free to plug in these and make sure you get the right answer. If not, you might have messed up your parentheses. So now let's go to the next one where we're going to manipulate or solve for a different variable. It's very similar, but with a twist. When you're reorganizing an equation to solve for a different variable, you're going to follow PEMDAS in reverse. And don't forget that you can either plug in answer choices if you're solving for a number, or you can make up a number if you're reorganizing with just variables to avoid manipulating the equation yourself. So if it's ever complicated or if you're not confident in your ability to rearrange a formula, you can use one of these strategies, which I'll cover here. But we'll start with just actually solving one properly first. And here we have the same equation, but this time we're going to convert 13 degrees Celsius to degrees Fahrenheit. So now I have this number instead of that one. So a little reminder again of PEMDAS. So I need to solve and get this in terms of F equals something, because I need to solve for F. So if I'm going to solve for F here, I'm going to go backwards. So addition and subtraction will be first. There is subtraction here, but that is in parentheses with nothing else, so I can't do that yet, because parentheses are the last thing. So next would be multiplication and division. So that 5/9 there. So if I want to move this to the other side, I have a fraction math video if you need to see it. But if I'm trying to essentially take this 5/9 times the parentheses, I need to do the parentheses and divide by 5/9, which is the same thing as multiplying by 9/5 on both sides, and that's why I get 9/5 Celsius equals F minus 32. There's no exponents here, so that just leaves the parentheses next, so we can basically just clear those out because there's only one thing there. And now we can move that 32 over by adding it to the other side, leaving me with 9/5 Celsius plus 32 equals Fahrenheit. At this point now, I can plug it and solve just like with the first type. So I can take that 13 degrees Celsius, put it in here, and solve. Order of operations, there's no parentheses here, or no operation in the parentheses. There's no exponents, so we'll do the multiplication and division first. So we'll do this 13 times 9/5 to get 117/5. Then that leaves the addition and subtraction, so I'll add 32. I have an equation or a video on fractions so you can know how to actually add these, but I don't recommend that you actually do that by hand because again, you have a calculator. You can plug in as early as right here or right here, whichever you're more comfortable with, to realize that your answer is going to be 55.4. So now, let's do this same one, converting 13 to degrees Fahrenheit. This time I'm giving you more like the actual test. It's multiple choice to figure out how could I have solved this without rearranging to solve for Fahrenheit if I'm not comfortable with what do I do with this 5/9. Do I make that 5/9 over here? Do I make it 9/5? If you're not sure, what can you do? So we can plug in our answer choices. We have these. So if I know that for whatever Fahrenheit over here, if I plug it in, I need to get 13 degrees Celsius. So I can just take all of these, plug it in for F, and see which one gives me 13. So I usually recommend that you try a middle answer first. The reason for that is if I try one in the middle, and I realize, oh, it's too big, then anything else above it is also too big, so I get rid of multiple choices at once. If there's only 4 choices, you really only have to try 2 things at most. So let's try C. So if I plug in that 63.7 for F, which is right here, we'll do the parentheses first, then multiply it by 5/9, or just put it right into your calculator. You get 17.61 degrees Celsius. So that's not 13 degrees Celsius, so it's not going to be 63.7. So if C is too large, then D is too large. So I just got rid of 2 answers right there. Then I can go try B. So here, I plug in the 55.4, put it into my calculator, and I get 13. That's what I wanted, so that's my answer. Now note, if I tried B and realized, well, that's also too big, then that already eliminated B, C, and D. I don't have to plug in A. I know it has to be A because it's the only answer smaller than B. Now, if you're not sure and you wanted to double check, feel free to plug in A, but you can save time because it's the only thing left. So now let's look at the other form of this where we're not actually plugging in any numbers and they just want to rearrange the equation. So they give us this equation and ask us, well, what is it if I'm solving for Fahrenheit? So we already did this by hand earlier, but again, what if I'm not comfortable doing that? What tricks do I have? Or what if this is a really complicated formula and I'm not so sure that I can do this accurately? Well, instead of plugging in our answers, because I can't plug in a whole equation, I can still just make up a number. Then I can plug that into the question and plug the same number into all of my answer choices and see what gives me the same thing, because they need to match. So to give you an idea, let's actually do it. I'm going to pick 50 degrees Fahrenheit as my random number. So first I'll plug that up into the question here. So I just put 50 in for Fahrenheit, put that in my calculator, and I get 10 degrees Celsius. So now I can take that 10 degrees Celsius, put that into all of these, and figure out which one gives me 50. So if I plug 10 degrees into A, I get 75.6. So that doesn't work. Plug it into B, I get 50. So I know that's my answer. To give you an idea of all the others, you'll get 37.5 and 23.3. So B is the only one that if I plug in 10 gives me 50, and if I plug 50 in here, I get 10. So they agree with each other. So that is going to be my answer. So now let's look at the last type of equation or problem they might give you, which is very similar to what we just did in the last slide. We're going to use the exact same method. And that's where we're going to rearrange an equation for an equivalent form. So we're not necessarily going to be changing it to solve for a different variable, but we're just going to simplify it. So the key word to know that we can use this strategy, because it's actually extremely common and very helpful for these harder questions towards the end of the test, is if you see is equivalent. So if they're ever asked which form of this or what equation is equivalent to this one, we can use this strategy of making up numbers. So that could test a wide variety of concepts, ranging from very simple to very complicated. But either way, you can skip all of them by just making up a number and plugging them in. So I recommend you just, when doing this, you avoid picking 0, 1, or 2, just because there's several situations where you can get the same answer with these. Because if you multiply anything by 0, you're going to get 0. Same thing, anything by 1, you're going to get itself. So same thing with the exponents. If you raise to a 1, you're not actually raising to anything. 2, you're generally fine, but there's just a few weird ones with that. But any other number, you'll be good. If you do have time, I would recommend that you plug in your answer or your chosen number to all the answer choices and make sure only one of them is going to agree. Sometimes you'll choose the magic number where there's actually 2 that work. If that happens, just pick a new number and plug it into just those that worked before until only one of them still works. It's rare, but it can happen. So on this next slide, I'm actually going to take an example from my Later Concepts 3, which is log rules video, to show an example of, hey, I can take what's a pretty complicated concept that a lot of people don't know, and I can just get the answer for pretty much any of the log problems without knowing anything about logs by using this strategy. So here it is. Which of the following is equivalent to the expression log of a over b? Here's my answer choices. Now, if you do know your log rules, you're going to know right away the answer is B. So it is helpful to have those memorized. It's faster. But a lot of people don't know them, and if you don't have time to memorize everything, you don't necessarily have to. Instead, we're going to use our calculator, make up some numbers, and figure it out. So we're going to pick some values for A and B. So I'm choosing 5 for A, 10 for B. If I plug A and B in, so 5 and 10, and put this in my calculator, I get negative 0.3. So now I can take that same 5 and 10 and plug it into all of these and see which one gives me negative 0.3. Well, A gives me 1.7, so that doesn't work. B gives me negative 0.3. C gives me 0.7. D gives me 0.69. So there it is, B. Because if it's equivalent to this, I have to get the same answer because they're equal. So both gave me negative 0.3 with these numbers, so that's my answer. So as you can see, you can save a lot of time or get away with not knowing a lot of the more complicated materials if you know how to take advantage of this strategy if you ever see is equivalent. But that'll do it for today. I hope you found it helpful. Good luck, and I'll see you on the next one.